Hello, welcome to PhysioDesigner tutorial series. In this tutorial series, we are going to create a model using morphological data. As the first example, we will show how to create a ring model which is composed of many of excitable units, each of which is modeled by Bonhoeffer van der Pol model, that is BVP model. At the end of this tutorial, we will observe this kind of simulation result, in which action potentials evoked by the external stimulus propagate on a ring. Okay, let's begin with a single BVP model. Firstly, let's download BVP model from PH database. You can access to the database from PhysioDesigner directly. Click an icon with globe and folder, which shows a dialog listing the models in the PH database. Here is a search function. Input keyword BVP and click search button. Now you see two models found. Select the model with ID 475 and click download button. Then in a small window, click open button to start download the model and open it in the canvas. Now you see, there are two capsule modules. Left one is of the external stimulus given to the BVP model, which is at the right hand side. Before creating a ring model, let's check the dynamics of the single BVP model. Right-click on the output of the BVP module and select Observe Time Course. This function calls Simulator Flint and run a simulation of this model automatically. Then the time course of a physical quantity corresponding to this output is shown in a window. Similarly, at the output of the external stimulus module, observe its time course. The stimulus is rectangular wave with height 2. When the stimulus is on, the BVP shows periodic oscillation. Next, let's prepare the ring shape morphological data. Create a module named torus, in which we will define a torus as geometrical data. Right-click on the module and select Edit Morphology. A dialog pops up, on which we can define geometrical data. Name can be any string. Here it is torus. Dimension is 3. Solid type is OK. Primitive in a combo box means that now we are going to use predefined primitive shape to define a geometry. Select torus in the next combo box, which is characterized by 6 parameters. You can find the meaning of each parameter after playing with different values a couple of times. When inner radius is 0, the torus becomes a solid donut. Here we use inner radius 0, outer radius 2, ring radius 10, start angle 0, and stop angle 360. Don't forget to change angle unit from radian to degree. Click Update button, then torus appears in the morphology tree at left-hand side. Click View button, you can see it in 3-dimensional space. By clicking Apply button, now the definition of the geometry is fixed, and its default segments are automatically set. Selecting one of segments, and click View button again. This time, the geometry is shown as a mesh object. It is possible to save this mesh object into a file, which might be used by other software. Click Save Mesh button, then Morphology Editor saves it in VTK format. Close the dialog. Right-click on the torus module again, and this time, select Show Image in the menu. Image Viewer is launched, and the mesh torus is shown. Image Viewer is not merely viewer, but can export it in different format. Now we export the torus into vol format. This describes a volume object, hence, parameters to define dimensions of the volume must be given. Here, let's use 24, 24, and 4. OK. Let's check the exported object. It's also possible to read vol format by image viewer. You see, it is a solid donut composed of many voxels. Principally, the ring model is created by replacing every voxel in the torus object by instance modules of the BVP module. One voxel has at maximum 6 neighbors. 2 neighboring voxels, that is, BVP modules, usually have bidirectional connections. To define the connection, it is possible to be mediated by other modules. In this case, 2 BVP modules are connected by a gap junction. Hence, We still need another modeling part representing a gap junction. We can find it in the PH database. Again, click the icon with globe and select gap junction. Please beware that, this time, in a small dialog after clicking download button, select add, not open. To make instance modules of BVP module, let's make it be a template module. Right-click it, and select template in the menu. Similarly, gap junctions that links BVP instance modules are also modeled by instance modules, so we have to also make it be a template. Okay, now preparation is almost done. To replace voxels in the object by instance modules, we can use create modules from volume object function. In the dialog, firstly, select the object file in vol format. The dimension is automatically set because it is written in VIF file which was created simultaneously with vol file. Template module must be BVP, which is selected in the combo box. The instances of this template module will replace the voxels. Then, at the joint module setting, select gap junction template module. This is used to link a voxel to the other. Set a kind of abbreviation to call this template module. Here, let's call the gap template simply gap. Finally, the way to connect two voxels are defined. Let's call one of two voxels voxel 1 and the other voxel 2. The first connection links from an output X of voxel 1 to an input V1 of gap. The second connection similarly links from an output X of voxel 2 to an input V2 of gap. The third connection links from an output I1 of gap to an input stimulus of voxel 1. And finally, the fourth connection links from an output I2 of gap to an input stimulus of voxel 2. Now we consider 6 direction neighbors. If you want to count oblique neighbors as well, it would be 26 directions. Click Create button to start the process to create instances and connections, which takes a little bit time depending on the size. Alright, instances and edges are created. Because there are a lot of them, they are shown compact way on the canvas. You can expand them, but it again takes quite a long time, because it means that plenty of edges linking instances are also drawn, and it is time consuming. Now, let's adjust parameters of stimulus. Start time is 15, and duration of the stimulus is also 15. Then, link an edge from the stimulus module to BVP instances. Drag mouse cursor from the output to BVP instances and drop it. Then a dialog opens, in which you can select instances to link the edge. It is possible to select some of them using labels assigned to the instances, but now this is inconvenient. You cannot know which instances are located where on the object, even their labels were automatically set to represent their coordinate. So, once let's go back to the torus module and define the site to give the stimulus. Call Show Image and open Image Viewer. On the menu, select Edit and select Voxels. Clicking the voxels, you can select voxels on the object. The selected voxels can be saved into a file. Close the dialog. Again, span an edge from the stimulus module to the BVP instances. Select the selected voxel file at the left bottom of the dialog. Now, the edge is connected to all of instances corresponding to the selected voxels. Clicking OK button, the dialog closes, and edges are created. The ring model is now completed. Let's save it. And give the file to Flint. Change the parameter values for simulation a little bit. Dump a data point every 10 steps, and simulation length is 100. Go to Output Variables tab, and filter physical quantities to be dumped. Here, only physical quantity that includes X in its name will be dumped. And click Run button to start a simulation. This takes time, so let's accelerate the movie. The simulation finished. Let's check the time courses. Randomly sampling several instances, it seems simulation went well, but we cannot see the propagation of excitation properly in this way. Export the simulation result into ISD format, which is a binary format used in Flint. And launch PhysioVisualizer, which can read ISD format data and reconstruct 3D object. To begin with PhysioVisualizer, the first step is to add a layer. Click Add button in the Layer dialog. There are two types of layers, but the first layer can be only a data layer. A condition layer can be defined on a data layer. Give a name of the layer. Select Flint format, that is ISD format, at data type. And select the data file. Value size corresponds to color depth. Most of cases 256 is enough. Value define the range of the values including in the data file. In the case of BVP model, usually their values fall in between -2 to 2. Hence, here set minimum as -2 and maximum 2. Then select physical quantity name. Here, the data contains only X, because we filtered physical quantities at Flint before running simulation. Size is the size of the object. Hence, it is 24, 24, and 4. To draw the object, PhysioVisualizer create VM files from ISD file. One VM file is created for a single time frame. In this case, Flint simulated for 100 milliseconds with 0.005 time step, and omp 1 data point per 10 steps. It means there are 2000 data points, and 2000 VM files will be created. To store those files, create a directory. Click OK button. There is a time slider at the bottom of the main rendering window. You can pick the knob and move it. Two spikes occur by the stimulus, and they propagate on the ring in two directions symmetrically, and they collide at the opposite side and disappear. There are 3 modes to display. If select View Raw Voxel mode, each voxel is shown more clearly. And for Windows mode shows dynamics on ZY, ZX, and YX planes. On PhysioVisualizer, it is also possible to observe time courses of selected voxels. Select time course graph from the menu. And select voxels by clicking. You can also move points. If you click the play button, time evolution starts, and the current time is indicated by blue vertical bar on the time course graph window. That's all for this tutorial. Thank you for watching until the end. See you next time. Goodbye.